Which of the following statements accurately describes the role of labeled and unlabeled data in semi-supervised learning in sklearn? A. Labeled data is used to train the model, while unlabeled data is ignored. B. Unlabeled data is used to improve the model's performance, while labeled data is used to initialize the model. C. Both labeled and unlabeled data are used to train the model, with the algorithm leveraging unlabeled data to improve generalization. D. Unlabeled data is used to create synthetic labeled data, which is then used to train the model. A. Labeled data is used to train the model, while unlabeled data is ignored. This statement is incorrect. Semi-supervised learning specifically harnesses the power of unlabeled data along with labeled data. It doesn't ignore the unlabeled data. False. B. Unlabeled data is used to improve the model's performance, while labeled data is used to initialize the model. This statement is partially correct. While unlabeled data does improve performance, labeled data isn't just used for initialization. It's a crucial part of the training process guiding the model. False. C. Both labeled and unlabeled data are used to train the model, with the algorithm leveraging unlabeled data to improve generalization. This statement is the correct definition of semi-supervised learning. The algorithm utilizes labeled data for explicit guidance and leverages unlabeled data to learn patterns, thereby improving generalization. True. D. Unlabeled data is used to create synthetic labeled data, which is then used to train the model. This statement is incorrect. While some semi-supervised techniques might involve creating synthetic data, it's not the primary way unlabeled data is utilized. The focus is on learning patterns from unlabeled data to improve model performance. False. C. Both labeled and unlabeled data are used to train the model, with the algorithm leveraging unlabeled data to improve generalization. Labeled data. Data points where the input features and corresponding output labels, example classes, values are known. Labeled data acts as a direct guide for the model to learn the relationships between features and outputs. Examples include datasets where images are tagged with their respective objects, example cat, dog, or text documents categorized as sports, politics, etc. Consider a dataset where each row represents a customer with features like age, income, and spending score. The labeled data would include these features and a corresponding label: high-value customer or regular customer. Unlabeled data. Data points where only input features are available but not the corresponding output labels. Unlabeled data helps the model uncover underlying patterns and relationships within the data. Imagine a large collection of customer reviews without specific sentiment labels. Unlabeled data can reveal trends and insights about product satisfaction or customer preferences. In the customer dataset, unlabeled data would include customer features like age, income, and spending score but without the high-value customer or regular customer label. Self-training. A semi-supervised learning strategy where the model iteratively uses its own predictions on unlabeled data to create pseudo-labels, which are then used for further training. This is often employed in image classification where the model predicts labels for unlabeled images and uses these predictions to fine-tune its performance. In a spam detection scenario, the model might initially predict spam not spam labels for a set of unlabeled emails. These pseudo-labels are then incorporated into training, helping the model learn more effectively. Semi-supervised algorithms. Algorithms specifically designed to handle both labeled and unlabeled data. These algorithms leverage the strengths of both types of data to improve the model's performance and generalization. Common algorithms include label propagation, graph-based methods, self-training, etc., used in various domains like image classification, text analysis, and fraud detection. Imagine using a label propagation algorithm for customer segmentation. The algorithm starts with labeled customers' high-value customer and propagates these labels to unlabeled customers based on their similarity in features. Label propagation. A graph-based semi-supervised learning technique where the model propagates labels from labeled data points to unlabeled data points based on their relationships in a graph representation. Used in social network analysis to classify users based on their connections and interactions. Imagine a social network graph where users are connected based on shared interests. Label propagation can start with a few labeled users and propagate their labels to connected users based on their similarity in interests. Graph-based methods. A class of semi-supervised learning techniques that exploit the relationships between data points represented as a graph. The model learns from the graph structure to infer labels for unlabeled data. Used in anomaly detection, where the model identifies outliers in the data by analyzing the graph structure. In a dataset of financial transactions, a graph-based model can identify suspicious transactions by analyzing the connections between transactions and users. Label spreading. Label propagation. Scikit-learn provides specific classes for implementing semi-supervised learning, enabling developers to leverage unlabeled data for improved model performance. These implementations are used in various applications like image classification, text categorization, and fraud detection, allowing developers to easily incorporate unlabeled data into their models. A developer can use label spreading or label propagation in scikit-learn to build a model for classifying customer reviews into positive, negative, or neutral categories using both labeled and unlabeled reviews.